For nearly 2 centuries, we thought we had a pretty good handle on the sun's predictable 11-year cycle. But what if we've been starting the clock late this entire time? A brand new discovery is forcing us to rethink the very beginning of the sunspot cycle, and we're about to dig into what that really means. All right, let's get into it.
Seems like a pretty simple question, right? When does it start? But as you're about to see, when it comes to our sun, even something that sounds that basic is packed with surprises. Okay, so the textbook answer, the one we've all learned, goes way, way back to 1844. We measure the cycle from one sunspot minimum, that's the quietest period of solar activity, all the way to the next one. That's been the official rulebook for generations.
Yeah, but here's the twist. The sun doesn't really play by our neat and tidy rules. It doesn't just close one chapter before starting the next. It turns out the new cycle is already getting started while the old one is still fizzling out.
So let's just quickly go over that familiar rhythm. We count sunspots, and when their numbers hit rock bottom, we call that the solar minimum. And for centuries, that's been our official starting point.
And this 11-year pulse, from low to low, has been a pretty reliable guide for astronomers. But there's always been this kind of nagging inconsistency, a little mystery that we're only now really starting to crack.
And that mystery? Well, it all comes down to something called the solar overlap. You see, new sunspots, the ones that actually belong to the next cycle, have this habit of showing up before the current cycle is even officially over.
So instead of a clean handoff like in a relay race, it's actually way messier. Think of it more like two songs blending into each other. The end of one cycle and the beginning of the next just overlap, creating this blurry transition.
And this brings us to the million-dollar question for solar physicists. If that solar minimum isn't the real starting gun, then what is? How do we find the true ignition point of the sun's incredible magnetic engine?
This is where we get to the really cool part, the hunt for what you might call sunspot zero, the very first spark that kicks off a whole new solar cycle. So, this amazing new research, a note by Jean-Guillaume Richard, decided to tackle this head-on. And we're not talking about a small data set here. They analyzed 17 full solar cycles, using data going all the way back to 1826. That is almost 200 years of solar history under a microscope.
But here's what makes this study a real game changer. For the very first time, they went back and pinpointed the absolute first individual sunspot group of the new cycle. And they did it for both the northern and southern hemispheres, for every single one of those 17 cycles.
So after all that digging through history, what did they find? Well, it all boils down to two incredibly important discoveries, two numbers that could change everything.
Okay, get this. The first discovery is about when the cycle starts. On average, the new cycle kicks off 1.4 years, that's about 16.5 months, before what we've always called the sunspot minimum. The race starts way before we even thought the starting gun went off. And the second discovery is where it starts. They found that these very first sunspots pop up at a super consistent latitude, 27.15 degrees, either north or south of the sun's equator.
And that's the 1-2 punch that makes this so huge. The cycle doesn't just start early, it starts in a really specific, predictable place. It's like finding a secret starting block for the sun's marathon.
Now, this new finding also helps sharpen our focus. You can see here, an earlier study from 2015 had pegged that starting latitude at around 34 degrees. This new, more detailed analysis brings it down to a much more precise 27.15 degrees. It's just a beautiful example of how science works, right? Each discovery refines what we knew before.
So we have a new starting time, a new starting place. Awesome. But why is this such a big deal? Well, it basically hands solar physicists a brand new and very tricky puzzle to solve.
I mean, really, what is so magical about 27 degrees? Why not 30 or 25? What is happening inside the sun that makes it choose that specific spot to kick things off, cycle after cycle?
And the plot thickens, because these first sunspots don't just appear at 27 degrees and then immediately start moving. Nope. They hang out there, at that latitude, for more than a year, before they finally begin that famous march toward the equator, the one that creates that beautiful butterfly diagram we all know.
So let's put it all together. What this really means is we now have a real physical starting line for the sunspot cycle, not just an arbitrary low point. And that's a huge challenge to our current models of the sun's internal dynamo. Any theory from now on has to be able to explain this. Why 1.4 years early?
Why 27 degrees? And nailing this down is so important, because the better we can predict the sun, the better we can protect our tech, our satellites, our power grids from those massive solar storms.
So, by finding the sun's true starting point, we've solved one mystery. But we've opened up a whole bunch of new questions about what really makes our star tick. It just goes to show you, there are still these incredible secrets hiding in plain sight. And it really makes you wonder, what's the next big cosmic rule that's about to be rewritten?